2, 1, and then you're going to turn it over and do that. Ready? 3, 2, 1, go!
Squeeze.
Squeezing one! And then vortex, short behind. Glug, we all figured you'd be a little bit slow. So that's good. So that's not the only thing you guys get to do. We still, this has a cornstarch. It's got a little bit of cornstarch. I'm just about out. Just a bit of water. That's what it has, okay? Okay. So I've been mixing this, but it still needs a little bit of mixing. So you three are going to get down here and mix it with your hands. Okay? While you're doing that, I'm going to laugh. No. While you're doing that, sorry. Just water. And before you actually start doing that, so I've got this here, and we're actually going to use that to wash off people's feet. So here's my question. What do you do, if you've got a garden hose, what do you do to make it spray further?
Stick your thumb in it.
Stick your thumb in it and make a smaller hole, right? Makes it go much higher up, right? So a smaller hole, in that case, we find makes it go much higher up. So here I've got a bottle. Which side is small? This one. So it's got 2 holes. Small hole to the right. This represents a small hole to the right. Bigger hole to the left. That's it. Okay. So, which one do you think will shoot out? Small one? Small? Ready to find out? Small holes on which side?
Right.
Yeah. My right, your left. You bet. Big holes on this side. Ready? Big hole over here, small hole over here. Ready to find out?
Yeah.
3, 2, 1. Almost the same distance, aren't they?
Squeeze it.
Oh, that was good.
Now, I can make the small hole go a little bit farther. Why? I can do it this way, where I put it on the bottom. Then it's higher pressure. I can make the large hole do it by putting it on the bottom. So why? It turns out that this is the same pressure down here. And the velocity of the fluid is purely determined by that pressure. So these are going to shoot out the same distance. The reason why the hose does when you put your thumb on is you've got all the water in that hose coming along and slamming into it, and then you're restricting the opening, and that's actually increasing the pressure. In a case like this, we're not increasing the pressure. If I increase the pressure, it'll affect both. I could increase the pressure by doing this too. All right, mix, guys. So this is cornstarch and water. Who saw the speaker stuff happening in there? Kind of cool stuff, right? So cornstarch and water has basically a small particle, solid cornstarch, mixed with water. Water's a fluid. Because of that, it exhibits both solid and liquid properties.
So it's going to get gold. It's like blue.
Which means that we can pour it. This is the mixture right here. We can pour it.
Oh, yummy.
But I can also pick up a little bit with my hand. Right? As long as I have force on it, what happens is you're essentially squeezing some of the water molecules out and the solid particles can lock together. There's other stuff going on with cornstarch.
Well, you have a question over here.
Yes?
Oh, well, when I was listening to Speaker Gang, like, we established that when you open it gets water, and when you, like, yeah, when you spin it gets water, and you get pressure off of it, like, it turns to liquid. So if they're doing that, it would turn straight to solid.
You're right. As they're doing it, it's actually harder for them to mix it. So someone said, you know what you should do? Get a drill and a paint mixer. If I got a drill and a paint mixer, what would actually happen is the stuff would become very solid. So punch it. And so we're going to use that principle to walk on it, because when you apply pressure, it, no, when you pressed on it, it did what? Solid or liquid? Solid. So if I pressed on it with my feet, it would be solid. But if I don't press on it much, what will happen? Okay, let's try it. You ready?
Yeah.
Now, if you guys would like to do it, what we'll do is we'll actually, these three get first dibs, and then we'll form a line there, but we'll do this first, okay? Ready? You can get your hands out now. Ready? Hands out. Want your hands washed?
Wash your hands, Eli.
Okay, good. So, first, can we walk across water?
No.
With cornstarch.
Yes.
We're gonna see. Ready?
Don't move. Don't.
But now, I'm kind of stuck, aren't I? Unless I move quickly.
It's like quicksand.
That's exactly right. And actually, so quicksand is a non-Newtonian fluid. Very small particles of sand with an upwelling of water. And what happens is if you hit that, you'll sink as long as the water's separating out the particles. But if you struggle against it, that's solid. You're actually squeezing the water out through the particles. But don't worry, if you're ever stuck in quicksand and it's not covered with a layer of water, if it is, oh well. But if it's not covered with a layer of water, lie on your back. You're less dense than the quicksand. You'll rise. Now, if you struggle, goodbye. Or you do that.
Oh, it's so cute to the ground. That's cool.
Now, I'm not going to lie on my back with this one because, well, I'm wearing clothes. And this is not life or death. It's not, okay.
And when you walk across, somebody should probably hold you so you don't
Right.
slip. You might, when you step in here, if you lost your balance, we would not want you
Ready?
to fall.
Real quick, Eli. Quick.
Gotta go fast. You want to? There you go. Good. Yeah. There you go. Come on out.
Come on.
If you want one foot to sink, go ahead, but leave the other foot out. It's gonna be easier. Go quicker. Ah! Quick.